section, let's see how to simulate the programs which we discussed in last video in an 8085 Java simulator. So this is the window while opening that simulator. So here we can have editor option. In this we can have lot of sample programs, and here setting is there in order to set memory range. In our case, we need to save the data from location 8100 onwards. That is 8100 contains number of elements in the array, and next location onwards we need to save the BCD numbers starting from 77. So we can set memory range using these settings. Set memory range. Here we can set the memory range. Whatever be the content available in this memory, we can clear it by means of this button. And another thing is that, so this part is registers. During execution we can see the register contents here. Stack pointer content, memory pointer, all this information we can obtain through this window. Here we can have an editor option. In editor we can write the program. Now we can enter our programs in editor window. After entering, we need to verify the programs. After verifying, we can assemble the programs. After assembling, this program will convert into machine code, which is starting from this location. Here the machine code is going to start in location 80B0 onwards. Let's see that one. So now I am clicking assemble. After assembling, it can be seen that there is no problem in this conversion, that is assembly language into machine code. There is no problem. So here we can see that in order to save the machine code of first instruction, it requires 3 locations starting from 80B0, 80B1, 80B2. So it is a 3-byte instruction. In order to complete this instruction execution, it requires 3 machine cycles. Total T state is 10. So corresponding to each instruction, we can see this information: byte, machine cycle, T states, etc. And this is the machine code corresponding to each instructions. Here we can see 2 methods are there for executing this program: run all at a time and step-by-step method. Run all at a time means the program is executed as a whole, so that in single click itself this entire program is executed and we can obtain the result over here. And second method is step-by-step method. In step-by-step method, each instruction is executed in step. That is, during first click it will execute the first instruction, and we can see the result over here corresponding to that instruction execution. During next click it will execute next instruction, and so on. So during each step we can see what is happening. So it can be used for debugging the program. Whether the data movement is correct or not, we can check by means of single step method. It is also known as single step execution method. So before doing this execution, here in our programs we need to enter the count in 8100. So for that one we need to move into memory. In memory there are 3 options: show entire memory contents. This entire memory content starting from 80B0 will show here. So it is convenient to show the required locations only. that is show only loaded memory location. Now we can enter count C into location 8100 as 05 like this, and after that if we are executing the program all at a time, we can obtain the results. So here one problem happened. What is the problem? In first location we can have the data 77, here we can have data 78, 79, after that 7a is coming. Why this is happening? This is happening because in our programs after addition we didn't included DAA instruction. Now let's correct that program by clicking editor. Here after ADI 01 we can add DAA instruction. Now again we can assemble. There is no problem. Now we can execute the program. So before execution we can enter the count in location 8100 as 05. After that we can execute the program by clicking run all at a time, so that we can obtain the result starting from 77 to 82. So in first location 77, next 78, 79, after 79 we can obtain 80 after we are providing DAA instruction that should be used immediately after ADI 01 or in general after addition operation. Now let's see what is happening during step-by-step procedure. For that one, let's see register. So in order to get that idea, we can go to editor, again assemble. Now I am going to memory in order to save the first data, that is count, into 8100, that is 05. After that I am clicking registers, then step-by-step method. Here our program is starting in location 80B0, that we need to show here. If it is another one, we need to type the same number, which is the starting address of our program. So in this case it's okay, we can click step by step. So before going to this step-by-step method, let's see the content of registers, flag registers, stack pointers, all these registers, counters, etc. So all are zeros. Here program counter is pointing the first instruction in our program, that is 80B0. Now if I am clicking step by step, then we need to forward. So after forward, see this instruction is highlighted. So after execution of this instruction, what will happen? H will load with 81 and L will load with 00. Let's check whether that is happening. So 81 is coming into H register and L register content becomes 00. And what is the content of 8100? We loaded 8100 content as 05. So that means 05 is now EM. So the first instruction is executed in one step. If I am clicking again forward, it will highlight the next instruction. So what is the meaning of this instruction? That 05 is loaded into C register. Now let's see the content of C register. Content of C register becomes 05. Now if I am clicking again forward, it will point next instruction, that is 80B4. So what this instruction will do? It will increment the memory pointer by 1. After execution of this instruction, content of HL pair is incrementing by 1. That means it becomes 8101. So there is no change for H content. L content is incremented by 1. Now if I am clicking again forward, that immediate data, that is the first data, is moved into that location. So M becomes 77, that is the first data. Next again clicking, that content, that is 77, should reach into accumulator, that is reached into accumulator. Again forwarding into that contents. Now the content of accumulator is 77, it is added with 01. See, content of accumulator become 78. Now again it is doing DAA, no change. So this result need to save in next location, so that next location L will increment by 1. So L becomes 02. So the result 78 need to load in this memory. For that one, again forward, Now that content is loaded into memory, which is pointed by 8102. That is, now M become 78. Again forward, count is decremented by 1. Now C register count is decrementing by 1. It become 4. Next click, this 04 is not 0. It will again add 01. Now content of accumulator becomes 79. Again it need to save into next location. So in this manner, this process will repeat until C register content becomes 0. If C register content is becoming 0 after execution of jump no 0 instruction, it can be clear that count is 0. After count becomes 0, it will stop the program. So in this way, single step method help us to debug the program.